So the next topic is called infeasibility. So that means we cannot find any solutions to the problem because of the constraints. So that means if we plot the feasible solution or region in a plot, it doesn't exist. So why do we have the infeasibility? Because maybe the leaders have very high expectations, and we don't have enough resources to meet their requirements. Okay. So, for example, if we still talk about producing the standard bags and deluxe bags. So, if we have one more constraint or one more requirement from the high-level leadership, so their requirement is that okay, you need to produce at least 50 standard bags and 360 deluxe bags using the previously provided resources. So what if we plot this additional constraints in the plot? This was the original feasible region, and here is the new requirement. So this part is the new requirement. So that means if we want to meet this requirement, the solution has to be there. But as we know from the production side, all the feasible solutions are here. So there's no overlap. So there's no overlap between those regions. That means we cannot meet those two requirements at the same time. So that means we don't have a feasible solution in this case. So in this case, we don't have a production plan. So that means we need to tell our supervisors, hey, your expectation is too high. We don't have enough resources. So if you want me to produce this many standard bags and this many deluxe bags, you have to meet my minimum requirements. So in terms of the resources, so we have to change our constraints such that we can reach to this feasible solution or feasible region. Okay? So based on our calculation, so we have to calculate what is the minimum requirements or in terms of resources. So for the first process, we have to have at least 17 hours. Right now, you only gave me 30 hours. At least I need 80 additional 80 hours. So the second one is okay. I have enough time with resources. The third one, the fourth one, I need more resources. Okay. So if we solve infeasible problem in Excel, the Excel solver, will tell us, hey, there's no feasible solution exists. So you have to check your constraints and redo the model or change the value of the available resources. So the other type of problem we may have is unbounded. So if we talk about maximization linear programming, that means your solution or objective function can be infinitely large. So there's no end of the search. So your solution, your objective value can be infinitely large. If we talk about the minimization problem, your objective function can be infinitely small. So if we look at this example, so we're talking about maximization problem, 20x times 10y. So here are our constraints. X has to be at least 2, y has to be less than or equal to 5, and they have to be non-negative values. So if we look at this one, because we don't have an upper bound for x, and our objective function is to maximize the whole function. That means x can be infinitely large. Then we don't have a solution. So that's unbounded problem. So this is our feasible region. So it can be extended to the x to the infinitely large, so we don't have a solution. There's no actual objective function value. So if we solve this kind of problem in Excel, so it will tell us, okay, hey, objective cell values do not converge, so there is no ending of the search. So we have to revisit our modeling and our problem to see what happened. So that's unbounded.